National Electrical Code Section 314.17 C2 states that raceway and cable opening protection for fire resistance shall not interfere with the operation of the enclosed equipment or wiring. National Electrical Code Section 300.3b states that conductors and raceways shall not be subjected to physical damage. Trapped conductors can overheat due to restricted airflow, leading to insulation damage and potential fire hazards. Fire caulk may react with conductor insulation, causing degradation or short circuits. Instead of plugging the conduit openings with putty, consider using wraparound caulk strips or intumescent gaskets that form a seal without impeding airflow. If the instructions require putty in the conduit openings, ensure that it is applied lightly and does not create a complete seal. Installing outlet boxes with conduit bodies provides additional space for conductors and allows for proper airflow and fire stopping. Consult with an electrician or fire protection specialist to ensure a safe and code-compliant solution. The phrase firmly inserted in the manufacturer's instructions may not be intended to completely seal the conduit openings. It could mean that the putty should be applied with enough pressure to form a tight seal around the conduit, but not to the point of obstructing airflow. Since the National Electrical Code does not specifically address the issue of fire caulk in direct contact with conductors, it is up to the electrician to determine a safe and effective installation method. When dealing with fire-rated outlet box pads and the application of fireproof putty, several concerns arise regarding electrical safety and code compliance. A key consideration is the potential for overheating conductors due to restricted airflow. According to the National Electrical Code, it's essential that fire resistance measures do not interfere with the operation of wiring. Plugging conduit openings with putty can impede airflow, potentially leading to insulation damage and fire hazards. Moreover, the National Electrical Code emphasizes that conductors and raceways should not be subjected to physical damage, including damage from incompatible materials like certain fire caulks. Instead of completely obstructing conduit openings with putty, electricians should explore alternative methods for fire stopping that do not restrict airflow. Wraparound caulk strips or intumescent gaskets are viable options as they create a seal without blocking air circulation. If putty is used, it should be applied sparingly to avoid creating a complete seal. Another approach is to install outlet boxes with conduit bodies, providing additional space for conductors and facilitating proper airflow and fire stopping. Consulting with electrical or fire protection specialists is crucial to ensure a safe and code-compliant installation. The manufacturer's instructions, while important, should be interpreted with caution. Terms like firmly inserted may not necessitate a complete seal, but rather a tight seal around the conduit without obstructing airflow. Ultimately, it is the electrician's responsibility to determine an installation method that adheres to safety standards and code requirements, particularly since the National Electrical Code does not explicitly address the direct contact of fire caulk with conductors. It's also good to understand the fire rating. Fire ratings are expressed in time, such as 1 hour, 2 hours, etc., and they represent the duration for which a barrier can withstand exposure to fire while still maintaining its structural integrity and ability to prevent the spread of flames and smoke. The specific requirements for fire ratings can vary based on local building codes and regulations, as well as the intended use of the space. Different areas of a building may require different fire ratings. For example, walls separating dwelling units in an apartment building typically need a higher fire rating than interior walls within a single unit. Walls and ceilings that form a fire separation, such as those around a stairwell or elevator shaft, also have specific fire rating requirements. The hourly rating indicates how long the assembly can maintain its fire-resistive properties. For example, a 1-hour fire-rated wall can withstand fire exposure for 1 hour, a 2-hour fire-rated wall for 2 hours, and so on. These ratings are determined through standardized testing procedures like those conducted by underwriters' laboratories or similar organizations. These tests simulate real fire conditions to assess the assembly's performance. Fire-rated outlet box pads contribute to maintaining the fire resistance of a wall or ceiling assembly. They prevent flames and hot gases from penetrating the opening created by the electrical box during a fire. This helps to contain the fire and slow its spread to other areas of the building. The putty used in fire-rated outlet box pads is typically an intumescent material, which means it expands when exposed to high temperatures. This expansion helps to seal the opening around the electrical box, providing an additional layer of protection against fire and smoke. The putty needs to maintain its properties and remain effective under high heat. Therefore, compatibility with other materials, especially electrical conductors, is a valid concern. The manufacturer's installation instructions are an important part of ensuring the effectiveness of the fire-rated outlet box pads. These instructions provide guidance on how to properly install the pads, including any specific requirements for preparing the surface, applying the putty, and sealing the opening around the electrical box. Following the manufacturer's instructions is crucial to achieving the intended fire resistance rating and ensuring that the installation meets code requirements. Building codes typically require that fire-rated assemblies, including walls and ceilings with electrical boxes, be installed and maintained in accordance with the manufacturer's instructions and applicable standards. Failure to comply with these requirements can result in code violations and compromise the fire safety of the building. Consulting with an electrician or fire protection specialist is essential to ensure that the installation of fire-rated outlet box pads meets all applicable requirements and provides the necessary level of fire protection. These professionals can assess the specific needs of the building and provide guidance on selecting the appropriate products and installation methods. To ensure proper and safe installation of fire-rated outlet box pads, firstly, review the manufacturer's installation instructions carefully. Secondly, inspect the fire-rated outlet box pads for any damage or defects before installation. Thirdly, prepare the surface around the electrical box by cleaning it of any debris or contaminants. Fourthly, apply the putty or other sealing material according to the manufacturer's instructions, ensuring that it completely fills the gap around the electrical box. Fifthly, make sure that the fire-rated outlet box pads are properly aligned and securely attached to the wall or ceiling. Sixthly, avoid compressing or distorting the putty or other sealing material, as this can reduce its effectiveness. Seventhly, do not use excessive amounts of putty or other sealing material, as this can create a fire hazard. Eighthly, protect the fire-rated outlet box pads from moisture and physical damage during and after installation. Ninthly, if you are unsure about any aspect of the installation, consult with an electrician or fire protection specialist. And tenthly, document the installation with photos and written records to demonstrate compliance with building codes and standards. Using a non-obstructive method of fire stopping is important because it minimizes interference with the normal operation of the electrical system and ensures the safety of the building occupants. Non-obstructive fire stopping methods allow for airflow around conductors and equipment, preventing overheating and potential fire hazards. They also avoid placing undue stress on conductors or other components, which could lead to premature failure or damage. By maintaining the integrity of the electrical system and preventing the spread of fire, non-obstructive fire stopping methods help to protect the building and its occupants from harm. Wraparound caulk strips and intumescent gaskets are generally considered non-obstructive fire stopping methods because they do not completely seal off the opening around the electrical box or conduit. Instead, they form a seal that allows for some airflow while still preventing the passage of flames and hot gases. This helps to minimize the risk of overheating and ensures the safe and reliable operation of the electrical system. In addition to preventing overheating and maintaining airflow, non-obstructive fire stopping methods can also offer other benefits. For example, they may be easier to install than traditional putty or foam sealants, and they may be more resistant to moisture and physical damage. Some non-obstructive fire-stopping methods are also designed to expand when exposed to heat, providing an additional layer of protection against fire and smoke. National Electrical Code Section 314.16 covers the number of conductors allowed in outlet device and junction boxes and conduit bodies. The number of conductors permitted in a box depends on several factors, including the size and type of box, the size of the conductors, and the presence of any devices or equipment in the box. The National Electrical Code provides specific tables and formulas for calculating the maximum number of conductors allowed in a box. These tables take into account the volume of the box and the space occupied by the conductors, devices, and equipment. It's important to note that the National Electrical Code also includes rules for derriting conductors in boxes. Derriting is the process of reducing the ampacity of a conductor to account for the heat generated by multiple conductors in close proximity. When conductors are derrited, the maximum number of conductors allowed in a box may need to be reduced further. The National Electrical Code provides specific requirements for derriting conductors in boxes, which must be followed to ensure the safe and reliable operation of the electrical system. In general, it's always best to err on the side of caution when determining the number of conductors allowed in a box. If you are unsure about the National Electrical Code requirements, consult with an electrician or electrical inspector for guidance. Following the National Electrical Code requirements for box fill is essential to prevent overheating and potential fire hazards. Overfilled boxes can trap heat and cause conductors to overheat, which can damage the insulation and lead to short circuits or fires. Overfilled boxes can also make it difficult to properly install devices and equipment, which can increase the risk of electrical shock or other hazards. By following the National Electrical Code requirements for box fill, you can ensure that your electrical system is safe, reliable, and code compliant. If manufacturer's instructions require putty in the conduit openings, ensure that it is applied lightly and does not create a complete seal, because a complete seal will restrict airflow and lead to overheating, and that it is also potentially a fire hazard. In this case, installing outlet boxes with conduit bodies provides additional space for conductors and allows for proper airflow and fire stopping, because conduit bodies are fittings that are installed in a conduit run to provide access to the conductors for pulling, splicing, or maintenance. They also provide additional space for conductors, which can be helpful in situations where the box is crowded. Using conduit bodies for fire stopping provides several benefits. Firstly, they allow for proper airflow around the conductors, which helps to prevent overheating. Secondly, they provide additional space for the fire stopping material, which can help to ensure that it is properly installed and effective. Thirdly, they can be used to create a fire-resistant barrier that prevents the spread of fire and smoke through the conduit system. There are many different types of conduit bodies available, including LB fittings, LL fittings, LR fittings, and T fittings. Each type of fitting has its own unique advantages and disadvantages, so it's important to select the appropriate fitting for the specific application. When selecting conduit bodies for fire stopping, it's important to consider the following factors. Firstly, the size of the conduit. Secondly, the type of conductors being used. Thirdly, the fire rating required. Fourthly, the ease of installation. Fifthly, the cost. Conduit bodies should be installed in accordance with the National Electrical Code and the manufacturer's instructions. It's important to ensure that the fittings are properly sealed and that the fire-stopping material is properly installed. If you are unsure about any aspect of the installation, consult with an electrician or fire protection specialist for guidance. Always seek professional advice from an electrician or fire protection specialist to ensure a safe and code-compliant solution. Firstly, they have the knowledge and experience to properly assess the situation and identify any potential hazards. Secondly, they can recommend the appropriate fire-stopping materials and installation methods for the specific application. Thirdly, they can ensure that the installation meets all applicable building codes and regulations. Fourthly, they can provide documentation to demonstrate compliance with building codes and standards. Fifthly, they can help to protect the building and its occupants from fire hazards. The phrase firmly inserted in the manufacturer's instructions may not be intended to completely seal the conduit openings. It could mean that the putty should be applied with enough pressure to form a tight seal around the conduit, but not to the point of obstructing airflow. This is a common misunderstanding when interpreting manufacturer's instructions for fire-stopping materials. It's important to carefully read and understand the instructions before installing any fire-stopping materials. If you are unsure about any aspect of the installation, consult with an electrician or fire protection specialist for guidance. Since the National Electrical Code does not specifically address the issue of fire caulk in direct contact with conductors, it is up to the electrician to determine a safe and effective installation method. In these situations, it is important to use sound engineering judgment and to consult with other professionals as needed. The electrician should consider the following factors when determining a safe and effective installation method. Firstly, the type of fire caulk being used. Secondly, the type of conductors being used. Thirdly, the temperature rating of the conductors. Fourthly, the ambient temperature. Fifthly, the ventilation in the area. Sixthly, the potential for moisture or other contaminants to come into contact with the conductors. Based on these factors, the electrician can determine whether or not it is safe to use fire caulk in direct contact with the conductors. If there is any doubt, it is always best to err on the side of caution and to use an alternative installation method. Fire-stopping materials are used to seal openings in walls, floors, and ceilings to prevent the spread of fire and smoke. There are many different types of fire-stopping materials available, each with its own unique properties and applications. Some common types of fire-stopping materials include putties, foams, sealants, and wraps. Fire-stopping putties are typically used to seal small openings around pipes, conduits, and cables. They are easy to apply and can be molded to fit any shape. Fire-stopping foams are typically used to seal larger openings around pipes, conduits, and cables. They expand to fill the opening and create a fire-resistant barrier. Fire-stopping sealants are typically used to seal gaps and cracks in walls, floors, and ceilings. They are flexible and can accommodate movement without cracking or losing their fire-resistant properties. Fire-stopping wraps are typically used to protect pipes and cables from fire. They are wrapped around the pipe or cable and secured with a fire-resistant tape. Fire-stopping material should be selected based on the specific application and the fire rating required. It's important to follow the manufacturer's instructions carefully when installing fire-stopping materials. The goal of fire-stopping is to contain a fire to its origin point for a specified amount of time, allowing building occupants to safely evacuate and firefighters to arrive and extinguish the fire. Fire-stopping materials help to maintain the integrity of fire-rated walls and floors by preventing flames, smoke, and hot gases from passing through openings created by penetrations. Proper fire-stopping is critical in passive fire protection. Passive fire protection refers to building design elements and materials that help to contain a fire and slow its spread. Fire-rated walls, floors, doors, and fire-stopping materials are all examples of passive fire protection measures. In contrast, active fire protection systems such as sprinklers and fire alarms require activation to suppress or detect a fire. A comprehensive fire protection strategy includes both passive and active measures to maximize safety. Building codes typically specify the fire resistance ratings required for different building elements based on occupancy type, building height, and other factors. These ratings determine how long a building element must be able to withstand fire exposure while maintaining its structural integrity and preventing the passage of flames and smoke. Fire-stopping materials must be tested and listed by a recognized testing laboratory, such as Underwriters Laboratories or FM Global, to verify their fire resistance performance. These listings provide information on the fire resistance rating, the types of penetrations the material can be used for, and the installation requirements. Building inspectors typically verify that fire-stopping materials are installed correctly and in accordance with the listing requirements during construction and renovation projects. Proper documentation, including product data sheets, installation instructions, and inspection reports, is essential for demonstrating compliance with building codes. Maintaining the effectiveness of fire-stopping systems over time is important. Building owners should periodically inspect fire-stopping materials for damage or deterioration and make repairs as needed. Any new penetrations created during renovations or alterations must be properly fire-stopped to maintain the fire resistance of the building element. Fire-stopping helps to save lives and protect property by preventing the spread of fire and smoke. By containing a fire to its origin point, fire-stopping allows building occupants more time to evacuate safely and reduces the damage to the building. Properly installed and maintained fire-stopping systems are an essential component of a comprehensive fire protection strategy. When installing electrical boxes and fire-rated walls, special attention must be given to maintaining the fire resistance of the wall assembly. Standard electrical boxes create penetrations that can compromise the fire rating of the wall, allowing flames and smoke to spread more quickly. To address this issue, fire-rated electrical boxes and outlet box protectors are used to seal the openings around the boxes and prevent the passage of fire and smoke. Fire-rated electrical boxes are designed to withstand high temperatures and prevent flames from passing through the box itself. They are typically made of metal and have a fire-resistant coating or insulation. Outlet box protectors are devices that are installed around standard electrical boxes to provide additional fire protection. They are typically made of intumescent materials that expand when exposed to heat, sealing the opening around the box. The National Electrical Code requires that electrical boxes installed in fire-rated walls be listed for use in fire-rated assemblies. This means that the boxes have been tested and certified to meet specific fire resistance standards. When installing electrical boxes in fire-rated walls, it is important to follow the manufacturer's instructions carefully. The instructions will specify the type of fire-stopping materials that must be used to seal the openings around the boxes and the proper installation methods. Common fire-stopping materials used with electrical boxes include fire-rated putty pads, caulk, and mineral wool insulation. These materials are applied around the box to fill any gaps and prevent the passage of fire and smoke. In addition to using fire-rated electrical boxes and fire-stopping materials, it is also important to properly seal any penetrations made by cables or conduits. This can be done using fire-rated cable ties, sleeves, or putty. Regular inspections of electrical boxes and fire-stopping materials are important to ensure that they are in good condition and functioning properly. Any damage or deterioration should be repaired promptly to maintain the fire resistance of the wall assembly. By following these guidelines, you can help to ensure that electrical boxes installed in fire-rated walls do not compromise the fire safety of the building. When multiple electrical boxes are installed in the same wall cavity, it is important to maintain the fire resistance of the wall assembly between the boxes. This can be achieved by installing a fire-rated partition between the boxes or by using fire-rated putty pads or other fire-stopping materials to seal the space between the boxes. The distance between electrical boxes in a fire-rated wall is typically regulated by building codes. The codes may specify a minimum separation distance or require the use of fire-rated barriers between the boxes. It is important to consult the local building codes to determine the specific requirements for electrical box spacing in fire-rated walls. In addition to the spacing requirements, the size and type of electrical boxes used in fire-rated walls may also be regulated. The codes may specify a maximum box size or require the use of specific types of fire-rated boxes. It is important to select electrical boxes that meet the requirements of the local building codes. When installing electrical boxes in fire-rated walls, it is important to pay attention to the details. Properly sealing all penetrations and maintaining the required spacing between boxes will help to ensure that the fire resistance of the wall assembly is not compromised. When it comes to fire-stopping electrical penetrations, several different methods and materials can be employed, each offering varying degrees of protection and suitability for specific applications. Firstly, fire-rated caulk is a common choice, offering a flexible and easy-to-apply solution for sealing gaps and openings around electrical boxes and conduits. These caulks are specifically formulated to resist the passage of flames and smoke, helping to maintain the integrity of fire-rated walls and floors. Secondly, fire-rated putty pads are another popular option, particularly for sealing around electrical boxes in drywall construction. These pads are typically made of an intumescent material that expands when exposed to heat, creating a tight seal that prevents the spread of fire and smoke. Thirdly, mineral wool insulation is a versatile material that can be used to fill large voids and irregular spaces around electrical penetrations. It is naturally fire resistant and provides excellent thermal and acoustic insulation as well. Fourthly, fire-rated sleeves and wraps are designed to protect cables and conduits that penetrate fire-rated barriers. These sleeves and wraps are typically made of intumescent materials that expand when exposed to heat, creating a protective barrier that prevents the spread of fire along the cable or conduit. Fifthly, fire-rated foams are another option for sealing around electrical penetrations, particularly in areas where access is limited. These foams expand to fill the void and create a fire-resistant seal. When selecting a fire-stopping method for electrical penetrations, it is important to consider the following factors. Firstly, the size and shape of the penetration. Secondly, the type of cable or conduit being protected. Thirdly, the fire resistance rating required. Fourthly, the ease of installation. Fifthly, the cost. It is also important to follow the manufacturer's instructions carefully when installing fire-stopping materials to ensure that they perform as intended. The ampacity of a conductor is the maximum amount of current, measured in amps, that a conductor can carry continuously without exceeding its temperature rating. The ampacity of a conductor is determined by several factors, including the size of the conductor, the type of insulation, and the ambient temperature. The National Electrical Code provides tables that list the ampacity of different types of conductors under various conditions. These tables are based on extensive testing and are designed to ensure that conductors are not overloaded. Overloading a conductor can cause it to overheat, which can damage the insulation and lead to a fire. In addition to the factors listed above, the ampacity of a conductor can also be affected by the presence of other conductors in close proximity. When multiple conductors are bundled together, they can generate more heat than a single conductor, which can reduce their ampacity. The National Electrical Code provides guidelines for directing conductors in these situations. It is important to select conductors with the appropriate ampacity for the intended application. Oversized conductors can be more expensive and may not be necessary, while undersized conductors can be dangerous and can lead to a fire. Consulting with an electrician or electrical engineer can help to ensure that the correct conductors are selected. Some fire caulk products may be corrosive or incompatible with certain types of conductor insulation. This can lead to premature degradation of the insulation and can increase the risk of electrical shock or fire. It is important to carefully review the product data sheets for fire caulk products to ensure that they are compatible with the type of conductor insulation being used. If there is any doubt, it is best to consult with the manufacturer of the fire caulk or an electrical engineer. Fire caulk is an important tool for fire-stopping electrical penetrations, but it is important to use it correctly and to select products that are compatible with the other materials being used. By following these guidelines, you can help to ensure that your electrical system is safe and code compliant. Intumescent materials are substances that expand when exposed to heat. This expansion can create a fire-resistant barrier that helps to prevent the spread of fire and smoke. Intumescent materials are used in a variety of fire protection applications, including fire-stopping, fire-resistant coatings, and fire-resistant doors and windows. The expansion of intumescent materials is typically caused by a chemical reaction that occurs when the material is heated. This reaction produces a gas that causes the material to swell and char. The char layer that is formed provides a protective barrier that helps to insulate the underlying materials from the heat of the fire. Intumescent materials can expand to many times their original size. This expansion can help to fill gaps and openings, creating a tight seal that prevents the passage of flames and smoke. Some intumescent materials also contain additives that help to cool the surface of the material, which can further enhance their fire resistance. Intumescent materials are typically tested and listed by a recognized testing laboratory, such as Underwriters Laboratories or FM Global. These listings provide information on the fire resistance rating of the material and the types of applications for which it is approved. It is important to select intumescent materials that are appropriate for the intended application and that meet the requirements of the local building codes. Intumescent materials are an important tool for fire protection. By expanding when exposed to heat, they can create a fire-resistant barrier that helps to prevent the spread of fire and smoke.